And now let's look at question 7. So question 7 states the ratio test can be used to determine whether the summation of 1 divided by n cubed, or the series, converges. Alright, so let's take a look at the solution, and this is in fact false. We can't use the ratio test. And to illustrate this well, first recall the ratio test from my earlier video on the, this is the video on absolute convergence and the ratio/root test. So the ratio test, if the limit as n approaches infinity of the absolute value of an plus 1 divided by an equals to L less than 1, then this absolutely converges and therefore convergent, and so on. But if it's equals to L and is greater than 1, or it goes to infinity, the limit, then it's divergent. But if it's equal to 1, then we can't use the ratio test. It's inconclusive. That is, no conclusion can be drawn about the convergence or divergence of the series an there. So let's take a look here. Let's just apply the ratio test and see what we get. So this is a summation from summation of 1 divided by n cubed. So we have, let's just write this like this. This is our an, the summation an, and in our case it's going to be 1 over n cubed. And then taking the ratio test, so the limit as n approaches infinity of the absolute value of an plus 1, so the term after it, divided by an equals 2, and in our case the limit as n approaches infinity of, and then now we're going to have a giant bracket here. So on the top, so we just plug in n plus 1 here cubed, so we're going to get a 1 divided by an n plus 1 cubed. Divide this by 1 divided by, well, just n cubed, like that, an all absolute value. And since n is always going to be positive, so either 0 is the lowest you can get, and this is cubed, so it doesn't matter what you do, these will always be positive, so this is always greater than or equal to 0. So basically we don't need to have the absolute value, so then we can just remove those. So this equals to the limit as n approaches infinity, so we can remove the absolute value signs. And also this is dividing by a fraction over there, so this one goes on top and this one goes on bottom. So this is the same thing as writing it as, so this one goes on top there, n cubed over n plus 1 cubed. And now we got to evaluate this limit, and well, the first thing that comes to mind is, notice the highest power n to the cubed. So we could multiply the top and bottom, if you recall our limit techniques over here. So we can multiply top and bottom by 1 divided by n cubed, so we can get rid of some of the n cubes there. And then this one here, this one n plus 1 cubed, yeah, that also will have an n cubed, so we're going to divide this also by 1 over n cubed. So then we're multiplying by this, so we're not actually changing this because these are both cancel out, so they're both 1, but we're going to do this just to manipulate this equation. Yeah, so the n cubes will cancel, so this cancels with this. And now this bottom part here, what do we end up with? Well, they have the same cube there. Yeah, 1 over n cubed. Basically, this is the same thing as writing, well, this equals to n plus 1 cubed times it by 1 over n cubed. It's the same thing as 1 divided by n cubed. And yeah, because this one here, if you 1 cubed is the same thing, then this one cubes both, so 1 cubed is still 1, and then n cubed, it will be this formula there. Now this one equals 2, we can combine the cubes, so we're going to have a setup like this, n plus 1 times it by 1 over n, and then put the cubed on top. Yeah, or put the cubed outside there. So now we have this, and we can multiply that inside. So what we'll get is, let's put the whole limit now. Limit as n approaches infinity. Now this n cubes cancel with that one there, so we have 1 over, and now this part here, we could just multiply that directly inside. So we're going to have a, this one will cancel with this. This and this will cancel, and this one will have a 1 over n there. So what we're going to get is a 1 plus 1 over n cubed, like that. Yeah, so that is what we'll have. Just put a cancel there. This one's going to be divided by n. There, this one goes to 1, that goes to divided by n. So anyway, so this is what we have. And as now that there's only one n variable, so this one, as this goes to infinity, this part here, 1 over infinity, approaches 0. So in other words, we're going to have, this limit is going to equal 1 divided by 1 plus 0 cubed. So in other words, that's just 1 cubed. This equals to 1. Like that. So that is our limit. So this equals to 1. So the ratio test is inconclusive. So like that. So I'll put here, so because it's 1, we go inconclusive. Inconclusive. So we can't use the ratio test for it. And I'll box this out. And here's fix up the box, put the arrows outside of the box. So that's inconclusive, so hence this is false.